Hello and welcome to 8.4 day 2. Here are your answers for day 1. We're going to be spending a little more time with our special parallelograms, and you're going to notice that I kind of assign all of the problems for this section because it does require a lot of practice, and it's good to kind of go through this and see all the different types of problems that they might present to you. Alright, so let's just jump into a proof here. We're going to do a couple proofs to start off, and then we'll do a couple more sample problems. If a parallelogram is a rhombus, then the diagonals are perpendicular. So in order to show this, what I want to do is I want to show that the two angles form a linear pair and they're congruent, because if they're a linear pair and they're congruent, they have to be 90 and 90. So what I want to do is I just want to pick two angles there, and I'm going to try to show that they are perpendicular. And this is an if and only statement, so you'll notice it says prove part of 8.11. I'm just going to prove that they're perpendicular. So what I want to do, and I keep in mind that since it's a parallelogram or it's a rhombus, we know that there's a lot of stuff. So we're going to just state that ABCD is a rhombus to start. That's our given. And then it has all the properties of the rhombus. So let's try to, I'm going to show that, we'll call that point M there. I'm going to show that these two little triangles are congruent. Let's see if I can do that there. So I know that AB is congruent to BC, definition of a rhombus. And I know that BM is reflexive. So I already have two sides congruent. And since it's a parallelogram, the diagonals bisect each other. So I know that AM and MC are equal. So I actually have side, side, side here. AM is congruent to MC. And that is, I'm going to say diagonals of parallelogram bisect each other. Okay, so the two triangles are congruent by side, side, side. And then angle 1 is congruent to angle 2. CPCTC. And then I'll say that angle 1 and angle 2 are right. And I'm going to say linear pair slash or plus congruent. Probably not the most technical reason there, but try to keep this proof within not going extravagant here. Okay, and since they're right, that makes AC perpendicular to BD. And that's it. So what you'll notice, with these proofs, showing angles are right are oftentimes annoying because you have to show that they're a linear pair of congruent angles. It's not impossible, but it takes quite a bit of steps here. Let's see, this one I think is a little easier, a little quicker. So if a parallelogram is a rhombus, then the diagonals bisect the opposite rays. So I'm just going to show this for one case. I'm going to show that these two triangles are congruent, and then those two angles, we'll call them angles 1 and 2 are congruent by CPCTC, which makes AC a bisector. And then it's basically, you can do that for all the angles there. So we're just going to do it for one case here. So we're going to start off with, we're given a rhombus, so we know all the properties of a rhombus. So we're going to say that ABCD is a rhombus. Given. And again, this is an if and only if statement, so you could prove it the other way as well, or you'd have to prove it the other way. I'm just going to show you this way here for this video. Okay, so because it's a rhombus, I know that AD is congruent to AB, definition of rhombus. All sides are equal or congruent. Okay, I'll mark that there and there. And then this proof is actually like extremely similar to the other one. AM is congruent to AM reflexive. And DM is congruent to BM. And that is the diagonals of a parallelogram bisect each other. So this one actually starts out identical to the other one. So the two triangles are congruent by side, side, side. And then angle 1 is congruent to angle 2 by CP, CTC. And that makes, since angle 1 and angle 2 are congruent, that makes CA an angle bisector. And there you go. And then you just do this if you wanted to complete this proof. You would do that for all the other triangles, but we're not going to do that. That'd just be excessive at that point. So there you go. And then these are the types of problems you're going to see in your homework. Basically, use the properties of the specific type of parallelogram that you're working with, and then you can apply that. And a lot of these are kind of straightforward. Classify the special quadrilateral. Explain the reasoning, and then find x and y. So the only thing I have here is 4 congruent sides, so it's a rhombus. And then, so that makes y plus 8, all the sides are equal. Y plus 8 equals 3y, you can solve that. And since it's a rhombus, it is also a parallelogram, and we know that consecutive angles of a parallelogram are supplementary. So 104 plus x equals 180, and then you could solve that. For 27 here, let's see, we have a rectangle. We have 4 right angles. So 4 congruent angles is a rectangle. We don't know it's a square, but we know it's a rectangle. And then opposite sides are equal. So you just set 4y plus 5 equal to 2y plus 35, solve for y. And then you could set x plus 31 equal to 5x minus 9. Because it's a rectangle, it's also a parallelogram. Opposite sides are congruent. This one here, we have 4 90-degree angles, so we know it's a rectangle, but the diagonals are also perpendicular. So this indicator here is the rhombus indicator. These here are the rectangle indicator. So because it's both, it is a square. Okay, so let's see what we got going on here. We'll find x. This little part here is referring to, and that's referring to there. So let's see, what I would do here, those two parts have to be equal because the diagonals are going to bisect the angles. So 5x is equal to 3x plus 18. Those angles are the same. And then this is the 2y and this is 10. It's kind of a smushed drawing, but 2y is going to be equal to 10 because the diagonals bisect each other because it's a parallelogram. This guy right here, we have opposite sides are congruent, and that's all we know. So this one's actually just a parallelogram. And then you could set the opposite sides equal to each other. You could set the opposite angles equal to each other. Solve for x, solve for y. And that would be it. So 32 through 52 is your homework. Make sure you give all these a try. If you have any questions with any properties, just see me in class. Thank you for tuning in.